And what you picked up was a review. You will have time to work on that in class tomorrow, but I gave it to you in case you wanted to work on some of it ahead. And then you can ask questions tomorrow. There's no review game. It's just doing your review. All right, so now we're looking at intermolecular forces. This, once again, just like our VSEPR, this only has to be worried about when you're talking about covalent compounds. So intermolecular forces are the forces that are holding the molecule together. So like what holds one molecule of water to another molecule of water. So intermolecular force is the force of attraction between molecules. They hold other molecules to other molecules. They vary in strength, but all of them are weaker than bonds that join atoms together. So we're going to be talking about 3 different types of IMFs, but all of those are weaker than a because they're just forces. All of those are weaker than a covalent or an ionic bond. And remember, when you see molecules or molecular formula, that tells you it is a covalent. That word should be used with covalence. All right, so we're going to look at 3 types of intermolecular forces. If you watch the video, then you'll have a little bit of a head start. So the strongest intermolecular forces exist between polar molecules. And something is said to be polar when it has a slightly positive side and a slightly, so in other words, not a full charge, negative side. We see that in water. Oxygen pulls the electrons more toward it, and so it's going to have a negative side where the hydrogens would have a positive side. So under forces that work for polar molecules, we have 2. One is called a dipole-dipole force, and the other one is called hydrogen bonding. So the dipole-dipole force is when the positive end of one dipole is attracted to the negative end of the neighboring molecule. So anytime you have positive, negative, they're going to line up. So they're going to be alternating charges, or plus minus is going to be together. So a dipole exists by equal but opposite charges that are separated by a short distance. And they are caused because, oh, this doesn't. There is unequal sharing of electrons. Don't really need that. Blank. And that unequal sharing is due to electronegativity differences. During our periodic trends one, so if you remember, electronegativity is the ability in a compound. You would never be talking about electronegativity if you were just talking about an atom sitting around. So the ability in a compound to pull electrons towards itself. So once again, in water, I keep on using that because it's so common. The oxygen is much more electronegative than the hydrogen, so those electrons are kind of shifted toward it, and that's what makes it a polar molecule. So an example of that, we can look at Cl. So on that one, chlorine is a lot more electronegative than hydrogen. So that means those electrons are going to shift toward the chlorine. So that's where my slightly negative side would be. And this is where my slightly positive side would be. So then if another HCl molecule came along and I had my hydrogen, it's going to align itself by the chlorine. So I have hydrogen, and then an oxygen. And this would be where we're talking about that force holding them together. Chlorine has partial negative, hydrogen has partial positive, so they're going to be attracted to each other. All right, everybody good on this? I'll move it up a little bit. So hydrogen bonding, which is a type, really not a bond, it's more really a force, so it's kind of named wrong, but water is a polar molecule, so we have something that is called hydrogen bonding, and it's the intermolecular force in which a hydrogen atom that is bonded to a highly electronegative atom is attracted to the lone pairs of the electronegative atom on a nearby molecule. So these are the strongest of the three IMFs that we're going to be looking for. It's responsible for the high boiling point of water because we know water has hydrogen bonding. It only happens with these three elements. So nitrogen, oxygen, and fluorine, that would have to be on one molecule. And then somewhere along the way, you would also have to have hydrogen combining with those. So just because something has a hydrogen, that doesn't mean it can form a hydrogen bond. And then the last one is called London dispersion forces. Sometimes you'll see it just called dispersion forces are on the video. Van der Waals forces. Those all mean the same thing. So IMFs is just an abbreviation for intermolecular forces. IMFs resulting from the constant motion of the electrons and the creation of a instantaneous dipole. They are the weakest of the IMFs. They act on all molecules. And it's the only one that nonpolar molecules are held together by. So like water is obviously held together by hydrogen bonding, but is also held together by London dispersion forces. So you would need to say that it's held together by both of them. So if we just kind of summarize those three, the strongest is going to be the hydrogen bond. And we said on that one, nitrogen, oxygen, fluorine. I remember it as no orange friends. Next one would be our dipole. And that is used with polar molecules. Then our last one is London dispersion forces. And all molecules have this. And it is the only one nonpolar. So once again, if you're asked what kind of forces are holding water molecules together, you should say hydrogen bonding, but then you should also say London dispersion forces, because those are part of everything that's held together, polar or non-polar. Right. Any questions on that? All right, over to our next page, and we're going to look at phase changes and phases and how they're affected. So IMFs affect the temperature. Remember, temperature is going to be related to energy. And so it's going to affect the temperature at which phase changes occur. George, wake up, sir. All right, so we're going to talk about the three different states. The first one is gases, and here you can just draw a little picture if you want to. They are very spread out. So that means they have the weakest IMF or interparticle force. They have a low density because they spread out so much, and they're easy to compress or expand. Then our liquids, we'll put them a little bit closer together. That is going to be intermediate as far as our IMF. They're going to have a little bit higher density. It's really hard to compress them, and we know it takes the shape of the container. And then the solid, draw those real close together. Remember, if you're drawing a solid, it probably needs to be at the bottom. Usually that's where a solid's going to exist. So these are the ones that have the strongest IMFs. And they also are high density, more high density than the liquids, and once again, cannot really be compressed or expanded. All right, let's talk about some of those physical properties a little bit more specifically. So interparticle forces are responsible for properties such as flow rate or viscosity. Does anybody know what viscosity is? Thick something is, so like water does not have much viscosity, but honey is very viscous. It's harder for it to flow. So if that's true, which one do you think has stronger intermolecular forces, the honey or the water? The honey, exactly. They're holding them together. They don't want to flow. So the more viscous, or like make syrup, anything that has a little bit of oil, anything like that, the more viscous, the greater the IMF would have to be. Melting and boiling point are probably more common. We talk about those a little bit more, and they are also dependent upon the strength of the IMFs. The stronger the IMF is, or the interparticle force, the higher the melting and boiling points. And we see this with water. Water has hydrogen bonding. Which is the strongest IMF, so it has a pretty high boiling point. And also melting point. what gives a lot of characteristics to water. If you remember in biology, things like adhesion, cohesion, surface tension, that's all because it has those hydrogen bonds. When you talk about vapor pressure, which we probably don't deal with as much, vapor pressure is kind of looking at how volatile or how easily something can evaporate. So the vapor pressure of a gas is also dependent on these forces. The stronger the interparticle force, the lower the vapor pressure will be at a given temperature. So if we have a low vapor pressure, that means it does not evaporate. Quickly. So something like water would have a low vapor pressure, but something like gasoline would have a high vapor pressure. So volatile liquids are ones that vaporize easily, and these are held together by weak. The weaker forces is going to hold those together. All right, so I'm going to show you just a question so you can kind of see how you might see these on the test. So usually questions about intermolecular forces are going to relate to one of the characteristics. So like maybe boiling point, freezing point, vapor pressure, something like that. So if we look at these three, and we know water has hydrogen bonding. So what kind of bonding is acetone going to have? And it says it's nonpolar. Which one did we say always is the only one that nonpolar can have? Yes, sir. London dispersion forces. And then we have my alcohol, which is polar. It wouldn't have hydrogen bonding, but it would have your dipole. So kind of do that and then think about which one is weakest and which one is strongest. So we're going to arrange the following in order of which will vaporize more quickly at room temperature. So which of those three do you think is going to vaporize the quickest? Which one of those three bonds is the weakest? The LD, London dispersion forces. So that's going to be our weakest. So that would make acetone evaporate first. Acetone is kind of like fingernail polish remover, and if you spill it, it will evaporate. And then next one, which would come. I should have written down the compound, not the. So my dipole would be acetone greater than alcohol. And then finally, I have my signs backwards, don't I? Let's try that for the third time. All right, acetone. Less than as far as force goes, then alcohol. And then also my water would be. So if we were looking, this is looking at forces. So that means my acetone evaporates easiest. So no, if we had those three things, let's say that we're looking for boiling point. So put those in order from highest boiling point. So don't have to list it as far as forces go, but from highest to lowest. So which one's going to have the highest boiling point, a strong bond or a weak bond? Strong. So that's going to put our water up here. And then in the middle, we would have alcohol. And finally, we would have some acetone. Probably would boil at a pretty low temperature. So notice also that like this says it's nonpolar. And so I would have to either give you that on the test, say that, or I would have to give you an electronegativity values and you would have to subtract them. But I don't expect at this point for you to be able to look at a drawing, a Lewis dot, and decide whether it's polar or non-polar, except for which one? Except for water, exactly. All right, so that's how you might see some of those on the test. There's a few of them, but there's also some on the practice. So work on some of your practice at home if you want to, and then you can come back with